Fabio Tiriticco, indeed, pronounced perfectly. Well done. My Twitter handle is TicoFab. It's a lot easier, actually, to pronounce than my family name. And there's two slides I want to show you, kind of logistic slides first. First one, what is this talk about? What is the talk focus? We're going to look a lot at reactive architectures. And then we're going to mix it with some data and sprinkle a little bit of blockchain delusion on it. Always fun to talk about blockchain. And so we're right there in the middle. As you can see, there's not going to be a lot of code. We're going to have some code, but not a lot. It's more about architecture approach. And then second slide I want to show you before we start is for questions and feedback, there's this fantastic website that solves the 1-minute problem that someone mentioned in the talks yesterday. If you go to that address and enter the code streaming, you can leave your questions while I do the talk, so you can take your time, write it properly, take your time, write proper English, whatever. And then at the end, I'm going to put them on the screen, so we can answer them as well. So that's it for introduction. Now I can introduce myself a little bit. I originally come from Italy, but I live in the Netherlands since quite a while, where I work as a freelance developer, but also as a community manager. I have this community called Reactive Amsterdam. We're about 2,000 members, so it's quite solid. It's been going on for a few years. And recently, I've also been the organizer of this conference called Kubernetes Community Days. As you can guess, it's about Kubernetes. And I have to say, organizing a conference is quite some work. So my personal respect to the organizer of this conference here. I know how much work it takes. Well, in fact, though, even if it takes a lot of work, for me, all the community efforts really are the salt of my being a software engineer. That's the best part of my job, I would say, being involved with community. But as we all know, software engineer comes with frustrations as well. And frustrations come in many forms. One of them is that projects don't get allocated enough time. Another one is you don't get enough time to improve your build system because it just works fine. So what works, you don't change it. This one I've actually heard it for real. Product owners that disregard the ubiquitous language in DDD terms because, quote, for what business is concerned, you can also call it Joe. And there's many other frustrations like that, especially on your workplace. You're not in charge of everything. You don't see the full life cycle of things. Maybe you only see a slice of the project you're working on. Well, for me, what really compensates for this, though, is side projects. Side projects to the rescue. Side projects give me energy. They let you learn whatever you want. It's your own little world. You make the rules in there, and you have all the fun you want. So this talk comes from a side project of mine. And I hope it's going to be interesting for everybody, even those who don't know much about blockchain and cryptocurrencies. Who here has done some cryptocurrency trading? Few people, okay. So I hope you haven't lost too much money. You're probably familiar, those few of you, with this website, CoinMarketCap. For those of you who've never seen it, this is a website that basically ranks all the major cryptocurrencies in the world. It ranks it by market capitalization, which means how much trading is happening, and lots of other criteria. Obviously, the most important one is Bitcoin, but there's like thousands of them. And so this website also has APIs, and you can interact with it. And then one day, I stumbled upon this other website, which is very unfriendly, called CoinMarketCal. So there's only one little letter difference right there. Super confusing. But anyway, what this website does is it lists all the events related to a specific cryptocurrency that are about to happen. So maybe there's going to be a blockchain conference that is about Bitcoin, or there is some release of Ethereum, or there is a hard fork. Forks are pretty common in the blockchain world. Anyway, and it tells you when that's going to happen, which coin is it going to be about. So my thought was, why don't I mix these two sources of data, what if I can understand how the price of a coin fluctuates based on a specific event? So what I'm really after in this project is a function like this, where a function that takes, say, a coin, say Bitcoin or Ethereum, and an event category, so for instance, a conference about Ethereum, and can predict a price fluctuation with some confidence. So, for example, would be a function that takes Ethereum and the conference is going to happen. Well, I know that the price is going to go up 10% with a confidence of 90%, something like that. So if I can find some patterns like this, then you're going to buy some before the event and sell it after the event. That's the whole goal. Let's see where we get. This side project is called Caterina, because it was the name of my niece. She was just born at that time. And there's two goals I have in this project. The first one is apply the reactive architecture principles. I've taken the reactive architecture course on the IBM Cognitive class platform. It's really cool. It's for free. You can take it at your own pace. And it's really, really well done. And the other one is learn more about sort of data and big data and how to manipulate it and have fun with it. For which I went and read that book. I bought it a MIP, from Manning, The Art of Data Usability. It's really, really cool, so I'm going to mention a few things about this book. But unfortunately, it was canceled. I don't know why, but they canceled it. It's totally disappeared from the website. I do have a PDF of it, though, so shall you want it? I've never said anything, but are you recording? Well, anyway, this book is canceled. Too bad. Let's dive a little into the data aspects of this project. What I learned from that book is that when we are approaching a data project, what we really are after is climbing the pyramid of wisdom, where at the bottom we have raw data, something that we just extracted brutally, let's say, and when we refine that, we can move to the next step, which is information, which is ordered, structured data, out of which we can try and extract knowledge, maybe find patterns happening in this data, and then on top of that, we have wisdom, which is the power that we have to use that knowledge and make decisions based on it. In my case, this would be, my raw data would be crypto events, so conferences and stuff when they're happening, and the price fluctuation of the coin about that event, around the time of that event, that I can filter, format, order, clean up is often needed, and then my knowledge would be then some price patterns in combination with one specific event, and well, reliable predictions that eventually led us by Ferrari. That's the very top of the pyramid where we want to get. Something else I learned from that book, phases of a data engineering project. You don't really need to read this, but what's important about these phases, such as design or collection management, is that each phase comes with a set of questions that you can start answering beforehand. I found particularly useful the last phase, closing. Start with the end in mind. Already plan the execution of your project with in mind how you're going to close it, what happens when you're going to stop. And so if you take all these phases and for each phase you try and answer all those questions, you get something like this. You're not supposed to read it as just to show that I've done my homework, but what I've really done is for each phase ask myself questions and answered it, and I have to say this sort of thinking beforehand, architecting, is, to me, it was really beneficial in trying to actually get this side project running. Because, we all have too many side projects. And we start another one before finishing the first one. Well, to me, answering this question gave me a much better roadmap. So I've been a developer and a product owner at the same time. I'm not sure. Well, it kind of helped. So that's it for the data part that I wanted to talk about, and now we can dive a little bit into the reactiveness side of this project. We're going to start with this tool called Event-storming. Has anybody used Event-storming before? One, two, three, yeah, a few, good. So event storming, what is it? Is a way to model your real-world phenomenon into your software domain. So to model your domain. What you can see, you have this wide blank canvas where you have some inputs on the left right there. Then we're going to do some internal processing right here. And we're going to have some output visible again in the outside world. And what's particular about event storming is instead of focusing on the entities and the actors that live in your system, it focuses on what happens. So one external event that we can start with in my system is, for instance, a new day has come. So every day, I will want to monitor if there's new event related to cryptocurrencies, and what is the price fluctuations of those involved coins. So for every day that comes, what do I want to do? Check crypto events. These orange stickies are events, and then these purple stickies are policies. So how do I want to respond to one event? Now, each policy generates then a command, like an action, something you want to do, which in my case is poll the event API. And then guess what? Each action probably generates more events. So in this case, for instance, maybe the polling failed, or maybe there's a new event that has been announced, and so forth. Each one of these events will then generate probably, you will have new policies associated with it, which will then trigger new actions, and so forth. So if you go ahead and fill the whole canvas, then you get something like this. And then eventually you'll get to this output column here, which is what you see. So maybe a forecast issued. I will get, I don't know, a Telegram message saying, buy Ethereum now. Or maybe you get an alert, because of course you monitor. You want to monitor and see what's going wrong, and things like that. And then what is happening in here is all your world. And there's a final touch to this event storming thing. That by seeing events and actions to take, see these yellow stickies that just appeared? You can make sense of who should be doing those things and how you can group these features and functionalities. So, for instance, in this case, moving a little bit towards domain-driven design terminology, then these yellow things will be aggregates. So it makes sense to have an event aggregate that pulls the event and emits, that pulls the event API and emits events after that. And then it makes sense to have a coin aggregate that instead pulls the coin price API and things like that. The top lane you see right there, it would be where I've gathered all this data, and someone is going to train a machine learning model that's going to tell me, when to buy and when to sell, kind of. So you get to all this modeling thing, and then you understand how you want to structure your code, and then from there, you can sort of create your bounded context. And so here, for instance, I got two bounded contexts. One is called the crypto service. One is called the prediction service. And what you define with bounded context, especially important, is their APIs. How do they communicate with each other? So this crypto service will look at the crypto events API, at the coin price, and things like that. And it will communicate with the other one via, in this case, an event bus. It could have been a REST thing. So I chose for an event bus. And then, well, each bounded context will probably need to store data somewhere. And by the way, you see lots of Google technologies here and Google services. And I'm not endorsing Google. This could have been any other services. But I have to say, I really like Google. Their services, for me, they just work. They're easy to use. Their documentation is very clear. So I'm quite happy with Google, and I would advise anybody starting something like this to try Google. Well, anyway, once we have defined our bounded contexts, then, by by bounded constant, and each one of them will be one service, then we can go one level of abstraction deeper. So if we look inside one service, what does it look like? Well, we have a couple of aggregates here, the coin aggregate, the event aggregate. They will do their respective jobs, plus some common objects right there. And so at this point, we're getting closer and closer to the actual implementation. And so, for instance, let's look inside one component inside one aggregate. And we are going to model this component as a stream processor. And I want to take just a very brief detour here about stream thinking. Why streaming? Why is it so successful? Well, I think lately it's so successful and popular because simply many processes in real life can be modeled as a stream. So for instance, let's say you are building an observatory that looks at birds passing by. Well, this could be a stream of birds, one after another, passing by. Or for instance, this image is going to be familiar for those coming from the Netherlands like me. What stream do you see here? Can I hear you? A stream of bicycles. Is that only a stream of bicycles? Stream of cars as well. Yeah. So you can start seeing things as a stream. And what you can see also already is that this stream of bicycles, probably it changes during the day. Probably at night there's not many bicycles there, but maybe at rush hour in the morning there's going to be a lot of people going to work. So streams have this thing where the emission rate, it's not known beforehand. And then the other cool thing about streams is that they can be manipulated in real time. So for instance, this one could be a stream of customers waiting to check out at a supermarket. Well, guess what? Once they get to the counter, each one of them becomes, in turn, a stream of items to pay for, streams of items to check out. And then when she's done, they become a stream of objects to put in your bag. So you have this entire flow of processing all the way from the source to the end. And what's really crucial here, I'm sure we've all been in this situation. If you are at the end here and you're not fast enough packing your things, you're going to slow the entire chain. And so the person down over here, then you have this very uncomfortable situation where you're trying to put as many items on the belt, but the belt is not moving, so you sort of try to put one on top of the other. And this is because something that happens at the very end of the stream can go all the way back and influence the beginning of the stream. You can piss off many people if you're at the end of the stream and are slow. This is something to be considered. In fact, once we have this thing, we can see that we can define a stream as a potentially unbounded stream of data that flows in a sequential fashion from a producer to a consumer. And two of the main challenges that come with it that we looked at is that first, the consumer cannot predict how much data it will need to handle. It's unbounded, so potentially infinite. And then challenge two, production and consumption rate can be different and change over time. Like the bicycle, at night there's not many, but during the day is probably plenty of them. So yeah, this was a little wrap why streams are so important nowadays. Now if we go back to our project and we try and model this as a stream, you will want to do it with some tool that helps you with these two challenges that are on the screen. So what's the business logic going to be like? Well, we are going to check, going from left to right. Every day, I'll have a tick that tells me, oh, a new day has come. I will need to do all the event-related stuff. So check the events API, and then put them on the event bus. It was Google Pubs Upflow. And then finally telling to a coin actor, which is not necessarily an Akka actor, but someone who is going to say, okay, there is a new event and we need to monitor the price of this coin. Well, what you can see here is this is a very high level. Of course, the block that you see in red, the events request flow, it needs to do lots of stuff. HTTP request and error, maybe their error handling right there. So in itself, that guy is can be also modeled as a flow. And then it's quite complicated. This API maybe requests an authorization token. So we have that token, we do the request via HTTP, and then maybe it fails. So we want to log failing. Maybe it can be successful, in which case we go on with the stream. But what if we get an unauthorized response? Then we need to trigger yet another flow, which is the flow that gets the new token. So as you can see, it's like a box that contains another box and so forth. And I think this is really the power of modeling real-world situation with streams. It's really powerful. When it's time for me to implement this, I'm very familiar with Akka, and Akka Streams is this fantastic module that has already lots of built-in resilience and tools to manage those two challenges we saw before. So just very briefly look at the code. The very top flow could look like something like this. We have a source that every day sort of emits one tick. This is a new day has come. We trigger this event request flow, and after which the outcome of that flow is put on event pub sub flow, and then we tell it to the coin actor. In this case, it's really an Akka actor, and we tell it, oh, there is this new event. Do something with it. A good practice is to embed this stream inside, in fact, an actor. As the stream might fail, stuff could go wrong, and so the actor could fail and restart the stream fresh. But lately, they also introduced after this restart source. So it's basically a source that has a capability of restart itself when things go wrong. And yes, I don't want to show a lot more code, but for instance, yesterday Jacek mentioned the powerful graph Dsl API. So if we have like a flow, which is a little more complicated, like this is the HTTP flow we saw before, then this graph DSL lets us sort of put all these boxes next to each other in a way that looks like the way we draw it on top. So what you can see with this weird, tilde arrow operator is you can map all the boxes really onto each component. So prepare request, HTTP flow right there, auth request flow, there it is here. And then this one is interesting. We also looked at it the other day as a partition component where there can be different outcomes of our request. And the way we would map this is by writing something simple like that, where that component takes an HTTP response as an input, and based on the status of this response, can decide to emit a different number. So 0, in our case, will correspond to a successful response. We will have a 1 will be an unauthorized response that then goes into the auth flow, or 2 will be an error. In fact, you have seen these little numbers in the little code snippet earlier. So request filter, there it is. Out number 1 will trigger the authorization request flow. So all in all, this is very, very powerful and very expressive. And the graph DSL is really powerful. You only want to use it though when you have complicated things to do, like loops like this, or merges, or partitions. In most other cases, you can use the previous sort of builder-like sequences. So to conclude our reactiveness chapter, what we've done is we started with event-storming, modeled our domain, and figured out what the bounded context would be and their APIs. Then we looked into one of the services, and then again down more into our business logic, and only finally some code. And this approach, these 5 steps here, event storming, all the way down to the code, are really a common approach in reactive architectures. You can use this to model lots of different problems in real life. And also something important that I would like to stress, I personally use Akka Streams because I'm familiar with it. But this bit of code could have been anything else, and all the work we've done before would be still very valid. So down here, you could have used FS2 or some other Zio streaming, I think. We're talking a lot about Zio in this conference. It could have been Erlang. It doesn't need to be Scala. But all that comes before is really a powerful way to model things. And another learning that I get from these slides myself is that reactive system design is different than jumping straight into hacking. Because that's what we do. Hacking is so much fun, writing code. You immediately want to see things working. Well, if you do all the steps before of thinking about your project beforehand, in my case, it helped tremendously. Having clear vision as I go, make less mistakes, waste less time doing things I don't need, and actually being able to close a project. All right, so we've built our services. The only thing we need to do now is put it on the cloud, because of course we're cloud native, we like cloud stuff. I'm not going to say much about this, but what I've done is I put it on Docker, and then run it on Kubernetes, on Google Cloud, obviously. In fact, I've done another talk about this. I did a webinar with Lightman at the beginning of this year. It's on YouTube, how to combine a little bit Akka cluster and Kubernetes. It was quite interesting. So this is all I want to say about this topic, except I want to share with you an invoice, the monthly invoice that I got from Google. So total was 18 euros. Not like a lot, especially considering that I'm going to buy a Ferrari in a couple of years. The most expensive thing was the compute engine, so actually running the thing, which amounted for almost 19 euros, but then Google is so nice, gives you a discount at the end. So in the end, it's not very, well, I mean, price is relative, but it's not super expensive, and it's very clear. Maybe you work with Amazon, and I don't know. Amazon invoices are kind of obscure to me. So yet another point for Google, I suppose. I think they should hire me, maybe. Anyway, we have collected lots of data. By now, we've done all our homework, all our work. So what can we see in this data that we collected? Well, first learning that I had, check your data every now and then, because I was, so happy. Oh, I got this running. Now I can forget about it. Wrong. I checked it for the first time after 2 months, and I realized something, really stupid. For instance, the Events API would talk about coin, and they would, Yoda is a coin about the Internet of Things. I'm not sure what it does, but that's where IoT comes from. The symbol that Events API was using is Miota, with this M. I also don't know what that is standing for. But then the Rates API, where I get the prices, would use the symbol Yoda without the M. So for 2 months, I wasn't able to correlate the two. Super sad. I lost 2 months of data. So you check your data every now and then, because something is going to go wrong. So I fixed that, and then eventually, at the end of 6 months of observation, I collected data about 2,000 events in 20 categories, about 500 different currencies, and a total of about 500,000 price measurements. Panic. What do I do now? I'm not a data scientist. I'm a developer. So what do I do now? The first thing that I looked at a lot of different things, and well, the obvious thing you want to think about is an average. So here we're seeing the average price of a coin. So this is the price fluctuation of this one event. It was a release about a coin called Eternity that took place on the 26th of November 2018. And then this is the price fluctuation on the 2 days before the event, and then on the 2 days after the event. And what I can do is I can look at the average So that's the average before, that's the average after. So in this case, the average after is lower. Not a very good sign, but what if I look at the average across all the events I collected? Well, it's distributed like this. The blue section is the only one where the average after was lower than before. All the other ones, actually the price increased. Maybe we're onto something here. So for instance, this is another event, a conference about Ethereum that took place on the 1st of November 2018, and the average, in fact, after is higher. Now, is that all I need to do? Is that all I need to see to just buy like there's no tomorrow before the event? Probably not. This would be ideally what you want to do if you had a crystal ball that sees the future. You buy at this point and you sell at that point. Great. But what if I do this? That's not good, and there's no way to know beforehand. So the average alone is not enough. I'm going to skip lots of the stuff I've done. I've went back to my high school mathematical and statistic books, looked at variant, covariance, contravariant, and all those things. In the end, what I found more practical is invent my own little criteria. And there's two of them. I call them spread and positiveness. So that's the graph we were looking at before. And then the spread would be, let's say in the loss in this worst case would be, let's say, $20, 20 euros. Then we put minus 20 here. The max possible gain would be 40 euros in that green case. Well, the spread would be then 60, the difference between the maximum worst possible loss and best possible gain, out of which about two-thirds, actually two-thirds, is in the green. So what I'm looking for here is events that consistently generate a positiveness which is closer to 100. Because then that means that no matter when you buy before and no matter when you sell after, you're still going to have a profit. I plotted the distribution of spread and positiveness, and this is what it looked like. So the spread was, well, focused here. Not very high, but it doesn't matter. We can get rich slowly. But the positiveness is a little worrying, though, because the distribution looks sort of normal, centered around 50, which it's the first sign that maybe events don't really influence the price all that much. It's a first sign in that direction, maybe. But still, there is a sizable piece where the positiveness is really high. So if we're able to get right there, then we're onto something. So I tried and filter all my events, looked at patterns where the positiveness was consistently above 85%, the event category appearing at least 5 times in my data set, of a coin appearing at least 5 times in my data set, and well, this narrows it down to 31 events. Not a whole lot. If I apply these criteria all together at the same time, we're down to 1 event category, which is community events, and 1 single coin. Ladies and gentlemen, are you ready to see what this coin is? We're talking about a coin called Holochain. That weird, kind of scary O is their symbol. They describe themselves as a blockchain written in Rust, BitTorrent plus Git plus digital signatures. Good luck in understanding what that means. The symbol for the ticker on the market is HOT. I'm not kidding you, it really is hot. They started trading in May 2018, and actually it's not doing that bad. Yesterday I checked and it ranked number 40 in market capitalization, so that's quite good. I mean, out of thousands cryptocurrencies. The peak value was $25 million at some point, which, I mean, yeah, we're reasoning on big numbers, so maybe we are onto something. However, if I look closer at this kind of data, at this kind of events, I remember I told you this was about community events. And then I look at all the community events about this coin. Is this reproducible? Well, it turns out that only 5 out of 10 observed community events gave such results, and these events didn't seem like a total world earthquake. They were like a meetup in Switzerland, think outside the blocks. That's kind of creative. There was a meetup in Sao Paulo in Brazil, 2 hours. Not sure how many people attended. Well, there was a hackathon in Amsterdam. I didn't go, unfortunately. I didn't know back then. But so, yeah, they don't seem like, you know, very, very global, world-shattering events. So, conclusion is these positive results are likely coincidental. And probably I need to find another way to get filthy rich. But, you know, there's always some learning. The data outcome of all this is, in fact, I can't confirm nor deny that there's a link between events and prices. And because I don't have remotely enough data. Remember when I told you, oh, I collected 500,000 price measurements and I was kind of scared? Well, that's kind of very tiny set. And problem is that the event data set grows too slowly. I mean, Bitcoin is the most famous, popular cryptocurrency out there. How many events about Bitcoin happen in 1 year? Maybe, I don't know, 20 or 30? That's not a lot. It really is not a lot. Especially because in the crypto world, you know, everything changes. You know, one day China says, oh, we're gonna introduce this, and it goes up, and then it evolves very chaotically and very quickly. But I had fun doing this. And if you, by the way, do want to try and do some analysis yourself, maybe you're a better data scientist than I am. My data set's still there, so we can talk after. Something I learned about doing this side project is, well, first, reactive architectures design and planning is very powerful, even for a small project like this one. We often hear that reactive architectures, especially at my meetup, I hear things, oh, but you know, you're not Facebook, you're not like PayPal, you don't need to scale to thousands of nodes. You don't need these kind of tools. But I find them very valuable, even for a small thing that's just going to run in one single node. Also, what I just said, data is never too much, and it misbehaves if left unchecked. And then this other thing, I can't stress it enough, think about things before starting hack together. At least for me, it's tremendously helpful. And it actually showed me that it is actually possible to finish side projects. That's probably the biggest learning of this adventure. These are some references of the stuff I talked about. I blogged about this thing extensively. There's a free architecture course. There's an event modeling tool for the event-storming thing. It's really powerful. And then plus all the Akka and cloud stuff that I talked about before. And so thank you for your attention very much. Do we have time for some questions, or does your stomach allow some questions before lunch? One slide back. Oh, yeah, this one. I am also going to check if there are questions on the Slido thing that I mentioned. Oh, there's one. Where's the other screen? Oh, there it is. Thanks for the talk. I was wondering, how did you approach testing in this project, and what challenges did you have when trying to do that? So, very good questions. Akka Streams comes with this test toolkit. And so I basically used that, trying to build my small building blocks from referentially transparent and pure functions. Then you can unit test that. But yeah, basically using the tools that come with Akka. Any other questions? I'm gonna answer one question even if nobody asks for it. All the prices you have seen, were with respect to euro. So price fluctuations about sort of fiat, currencies that are backed by a government. But someone asked me, have you tried to cross-correlate price fluctuations between different cryptocurrencies? So maybe with respect to Bitcoin. And I thought that was a very good idea, but I didn't do it. So if you want to give it a go, again, my data set is available. If you do become millionaire, my Twitter is somewhere in the slides. Let me know. But yeah, that was it. Any other questions? Real questions from you? No. Well then, I think we can all enjoy your lunch. Thank you very much.